Jamb candidates, welcome to the continuation of our chemistry calculation, treating all the chemistry calculations, the important ones, okay? The ones that are commonly repeated, all right? If you need any help, you need any material, especially the file containing the Jamb most repeated questions, or you need last-minute preparation plan for those that have not been preparing, this is my WhatsApp number. Oh yeah, send me a message on WhatsApp, okay? This is my WhatsApp number, okay? No lose guard though. All right, today we are looking at Iupac Nomenclature. We want to know the Iupac Nomenclature rules, okay? That's naming organic compounds. Naming what? Organic compounds. So we have to know all the basic rules. I will teach you all the rules and it's going to be very, very easy for you. You are going to be able to name any organic compound that Jamb sets or that Jamb decides to set on your Jamb UTME day. All right, let's look at the rule, okay? Rules, okay? What are the rules of Iupac Nomenclature or naming organic compounds, okay? Remember, the full meaning of Iupac is International Union of Pure and Applied Chemistry. International Union of what? Pure and Applied Chemistry. Okay, so first things first, when naming an organic compound, please, if you haven't taken my lesson on Introduction to Organic Chemistry, please do before you take this lesson. So that way you don't come to feel lost at some point, because you get some kind of things where I will mention, where I don't already explain for that lesson. To not make this lesson too long, now make me be separate, okay? Go and take my lesson, Introduction to Organic Chemistry. Just check the playlist, you will see it there. All right. So the first is what? Towards identify the longest carbon chain, known as the parent chain. Some textbook will say identify the longest continuous chain. I will teach you everything. So identify the what? The longest carbon, that's carbon to carbon bond chain. All right, it is usually called the what? The parent chain. It's called the what? The parent chain. All right, so that's the first thing to do. All right, when you identify that, then you start counting the carbons in the parent chain. All right, you start what? Count the carbons in the what? The parent chain. All right, the parent chain that you have identified. All right, and there is a method of counting, okay? How would you know if you are supposed to count from right to left or from left to right? How do you know if you have to count from here to here or from here to here? For example, you are given something like this, C, you have hydroxide here, for example, just for example, okay, see this one now. So how do you know if you have to count from here, okay, or from here? Are you to count the carbon atoms? This one is the parent chain. Now this is the longest carbon to carbon. Are you to count from here 1, 2, or you have to count from here 1, 2? How are you going to count? Is it from left to right or from right to left? How do you know? You know this through hierarchy. It's called the hierarchy. Through the what? The hierarchy. This hierarchy is what guides us during counting. Okay, the hierarchy says favor. The first that you should favor should be the functional group. Functional what? Group. Favor the functional group first. Okay, before you now favor double or triple bond. That's if there's double or triple bond in the what? In the compound that you are naming. Okay, double or triple bond. Okay, so the first is what? You favor the functional group first. Then the second, you favor if there's double or triple bond. You favor the double or triple bond. Then the third is finally the substituents. Okay, so you are going to consider functional group first before you consider double bond or triple bond, before you now consider what? Substituents. All right, we are going to know what substituent is. All right, I already taught you functional group and double bond. All right, so looking at this organic compound we have here, we have only one functional group here, which is what? OH, the alcohol group, or the alkanol group, the ol, okay, the ol, OL. All right, so that's what we have. So on the hierarchy, if we want to start numbering, we are going to start numbering from where we have the functional group, numbering it in a way that the functional group we have the lowest number. So when you number it from the functional group, you will have the lowest number from there. For example, if I number from left to right, that's a number from here 1, 2, 1, 2. Can you see? From here to the functional group, it has 2. Okay, it has 2. It's 2. But if I number from where I have the functional group, this one OH, and I will now start from here 1. Can you see? 1. So it's having the what? The lower number. Okay, 1 instead of 2. 1, 2. Like if I count from here. So you are supposed to number towards to favor the what? The functional group. But if you don't have functional group in the organic compound, you will now look for double bond. If you have double bond there, before you now you now number to favor the double bond, the same thing. So that when you number from the side that you have the double bond, you are going to get the what? The closest number from there. You number it in such a way that you get the closest number from there. If you don't have a double bond or you don't have a triple bond in the organic compound, you will not consider substituents. Okay? You start considering what? Substituents. For example, maybe you now have the functional group at the middle. If you number from left, it gives you the same number. You consider number from right, it gives you the same number. Just pick one, since not the same thing. Pick one and carry on. That's the rule. When numbering, follow this hierarchy of numbering. All right. So let's move on to the next. All right. We have to know some stuffs. They are called prefix and suffix. Prefix means before or beginning. Okay. Then suffix means ending. Okay. Prefix means beginning. Suffix means ending. So if we have a word now, for example, we have alkane. Okay. Alkane, for example. What is the prefix? The prefix is what? This R is the prefix. AL, the first word syllable. Then the suffix is what? N. A-N-E. Ending letters, okay, is the suffix. Alright? So let's bring out some list of the prefix. We already discussed this list of prefix before. Alright? And the list of prefix, they have what they represent. They have a particular number they represent. So we are going to know the number they represent. Okay? When you have, let's write prefix. Okay? When you have one carbon atom, like here now we have two carbon atoms, straight chain. Okay? The longest chain is one carbon atom. When the longest chain is one carbon atom, one carbon atom, the prefix that you are supposed to use is what? Met. When you have two, the longest chain is two carbon atom, the prefix that you are supposed to use is what? Et. It's et that we start it. When you have three, I already taught this in organic chemistry, introduction to organic chemistry. When you have three carbon atom, longest chain of carbon atom is 3, you are going to start it with what? The name. You are going to start it with what? Probe. Okay? When you have four longest chain of carbon atom, you are going to do what? You are going to what? Start it. The prefix will be what? Boot. When you have 5, okay, 5 straight chain of carbon atom, the prefix will be what? You will start it with pent. Okay, when you have 6 longest chain of carbon atom, you are going to start it with what? Hes. When you have 7 longest chain of carbon atom, you are going to start it with what? The prefix will be what? Hept. When you have 8 longest chain of carbon atom, you are going to what? Start it with what? Oct. When you have 9 longest chain of carbon atom, you are going to start it with what? You start it with none. Okay, none. When you have 10 longest chain of carbon atoms, you are going to start it with what? 10 longest chain of carbon atom, you are going to start it with what? Deck. Okay, 11 still there. On deck. 12, 13, and so on and so forth. But most of the time, now they stop. From O-level exam, now here they stop. They go 11 and so on and so forth. Just know all these, okay? 1 met, 2 et, 3 probe, 4 boot, 5 pent, 6 hes, 7 hept, 8 oct, 9 none, D deck. Alright. So we are going to look at what? Suffix next. Suffix. This one is prefix. Okay, let's look at suffixes. Okay, suffix. Alright. So their list include suffix can be a functional group, or it can be a what? It can be a homologous series. Okay? It can be a functional group or homologous series. For example, you have suffixes like ending in ane. You have another one like in. You have another one like ein. Okay? All these are suffixes. Suffix can also be functional group too. Okay? It can also be functional group. Functional group. Okay, suffix can also be functional group. You can see it as, for example, I already taught this introduction to chemistry. For example, all, which is the what? The alcohol functional group. Okay, alkanol functional group, or alcohol. Okay, alcohol is C. So alcohol functional group. Okay, you still have different functional group. I'm just writing the most common. Okay, you can have al, which is the what? The alkana or aldehyde. Aldehyde. Okay, you can still have which other one again? You can have O8. These O8 are the esters. Okay, esters like ethanoids and so on and so forth. You can have on, which are the what? The ketones. You can have oic, which are the what? The carboxylic acid. Okay, carboxylic acids. Okay, so all these are, suffixes. I told you that prefix means starting, beginning. Suffix means what? End, ending. Okay? So if we bring a prefix and a suffix together, for example, let's take met and let's take one suffix here. Okay? Met. We are now going to have what? Met. We take one suffix here. Methane. Can you see? So it means that there is only one continuous chain of carbon atom in the compound, and the suffix, the name, okay, the name of the group, the functional unit is what? Is ane. Can you see? Ane. Okay, so this is a what? Is a functional group. All right. So this prefix that you are seeing here, if I carry one of these suffix, for example, this ane, put R, join all of them for here, you can call all of them with homologous series. Homologous within series. Now you can call all of them. They are now going to be homologous series. Homologous series is a group or a family whereby each successive member differs from each other by what? CH within 2. Okay? CH2, alkyl group. Okay? CH what? 2. Now the difference between each member. So methane, for example, we differ from ethane with just CH2. Okay? Propane, we differ from butane with just what? CH2. And so on and so forth. Remember, for these suffixes, we also have other functional group like amine. Okay, we have amide. We have nitrile, used for explosive, and so on and so forth, etc. All right. So now then beyond this one, the first thing for the rule now to waiting, identify the longest carbon chain, which is the parent chain, the longest straight carbon chain. After that, you count the what? The carbon to carbon what? Chain, the carbons, the amount of carbon you have in the longest chain, which is the parent chain. Then after that, you are going to find the what? The prefix. Okay? When you don't count the what? The carbon atoms within inside the longest chain, now you count the assigned prefix. Okay? Given according to what we get here. Is it 1? You give it met. Is it 2? You give it 8. Is it 3? You give it group, and so on and so forth. Then after that, you identify the suffix. Is it alkane? 1 bond. Is it alkene? Double bond. Is it ine? Triple bond. And so on and so forth. Then after that, you identify the functional group name. What's the name of the functional group? Is it the all? If it's all, this suffix ane will not end in ane anymore. It will not end with all. If it's al, this suffix you remove this one and you put al. It will not be al. If it's o8, this suffix you remove it, you will not put o8, and so on and so forth. Just like that. Very easy. And after that, you will now identify if there is substituent. Identify. The next step is what? Identify. Identify substituents. Okay, substituents. Identify substituents. Substituents include, it can be from something that is not even part of organic chemistry. Okay, it can be an atom, or it can be a homologous series that has lost one hydrogen atom. Okay, a homologous series that has lost one hydrogen atom. For example, you have ethene. For example, now ethene. Okay, ethene. This one is ethene. Okay, ethene. Okay, this is ethene. When it loses one hydrogen atom, this now turns to what? Ethyl. This is a what? A substituent. It will now be called what? Ethyl. 1, 2, 3, 4, 5. Ethyl. If it's methane, it loses one hydrogen atom, it becomes what? Methyl. All these are substituents. So substituents include, for example, you can have methyl there. You can have ethyl. You can have butyl. All these are substituents. You can have propyl. Okay, and so on and so forth. I tell you that what's pentane, butane, alkane, methane, ethane loses one hydrogen atom. That ane turns towards I. It's not I though. It's not I though. Not this one though. It turns towards I. This ane turns towards I. All right. So you also have substituents like. Okay, let me put etc here. You also have substituents like. CH3, which is methyl. This one ethyl is like C2H5. 9 here. 1, 2. That's what. 2 carbon and 5 hydrogen atoms. That's what we have here, and so on and so forth. Okay. Then we have substituent like chlorine. You have bromine. You can have nitrogen safe. Like for the N, the organic compound that starts with N. You can even have iodine, etc., and so on and so forth. Okay. So just know this. You identify the substituent. You identify what? The substituent. Okay. So remember what I taught you related to what? Numbering of the carbon, the longest carbon chain. When numbering, number to favor the functional group first, if there's functional group. Okay. So that if you number from where you have the functional group, it's going to have the lowest number. Okay. When you number from where you have the functional group, it's going to have what? The lowest number. If there's no functional group, you can think of double bond and triple bond. If there's no double bond and triple bond, then you now think of what? What do you think next? Substituent comes next. So the hierarchy is functional group first, double bond and triple bond second, then substituent next. So the next step is what? Indicates the position of the functional group. Indicates the position, okay? The position of the functional group indicates the position of the functional group with a number. Okay, with a what? With a number. How are you going to do that? I will show you. Okay. For example, we have C here, C here, C here. And here we have OH functional group. Here is hydrogen, here is hydrogen, here is hydrogen, here is hydrogen, here is hydrogen. For example, this. Where do you have the functional group? You have it in 2. 1, 2 carbon. Can you see? 1, 2 carbon. Okay, 1, 2. The second carbon, carbon number 2. 1, 2. That's where you have the what? The hydroxide. Okay, the OH, which is what is called the OR, the alkanol, okay, or the alcohol. All right. So here, since you have it here, you are going to indicate the position with a number. So you are going to indicate it with 2. You will now say 2 all. Since this one is what? The all functional group, all. You will now say 2 all. Okay, all. If you have it here, for example, now, if you have it here instead of here, because you are numbering to favor the functional group, to make the functional group have the shortest number from your numbering, you are going to now, you are going to call it what? Since you are numbering from this side, now you are going to call it 1. Okay, 1. Since it's first carbon, 1. So it will now be what? 1 all. Okay, so that's what this thing is trying to explain. All right. The next is what? Use di, tri, tetra to name substituent amounts. The amount of substituents. How many substituents dey? Now di, tri, tetra. You go take what? You go take name. Okay. So use what? Use di, tri, tetra. Okay. To what? To name substituents. Substituent what? Substituent amount. How many substituents dey? So if you have 1, no need to put anything. Okay. But if you have 2, you use di. Let's say you have 2 chlorine here now. For example, 2 chlorine, you have 1 up here, you have 1 down. Okay. You are going to name it, or you have 2 up here. You are going to say dichloro. You are going to say dichloro. That's 2 chloro. Okay. If it's 3, maybe you now have 3 chloro there. You are going to say what? Try the substituent. If you have 4, you are going to say what? Tetra, the substituent. Tetrachloro, and so on and so forth. As simple as that. Easy. Okay. This one is supposed to have mono, but no need to put mono. Okay. Just put chloro instead of monochloro. No need for monochloro or monobromo. No, just say chloro. If it's only 1, or if it's 1. Ensure you get used to the functional units, their symbol. We already taught this. Okay. I already taught this in Introduction to Organic Chemistry. So go get familiar with it. For example, you have C bonded to what? Oxygen. Okay, this one is called what? The one. Okay, the one. That's the ketones. Okay, that's the functional group. You have C, double bond O, 1 bond H, bonded to what? An alkyl group. For this side, or this side, it bond to alkyl group. Okay, this one is what? It's called the R. Alkana, aldehyde, and so on and so forth. Then you have another one again. Okay, you have another one again. C bonded to what? O. C bonded to OO. Okay, bonded to OO. This one is OH. OH. This particular one is OH. Okay, when you remove 1 hydrogen atom from carboxylic acid, it becomes what? OH. All right, that's the what? The esters. The esters. Okay, that's that for that. You have a lot, many. There are plenty. So forget about these rules. When you are naming these organic compounds, it's going to be easier for you. All you have to do, just understand what I'm trying to explain to you. I want you to understand everything so that you can name any compound that Jamb brings to your face. All right. So the next rule is what? Is name what? Name in alphabetical order. Very important. In alphabetical order. Name in what? In alphabetical order. Okay. For example, you have chloro, and you now have bromo. And you now have a functional group, all. And this all is what? Is the alkanol, the alcohol. Okay? Okay? Alkanol group. Okay? So this group, if you want to arrange the name, okay, when you are naming the organic compound, if you want to arrange the name in alphabetical order. What should come first? Remember, this particular one, this all, okay, is a suffix. That should be, it go there the last side, now it go end down. So this one no concern the beginning part. So this one is suffix, no be prefix. So for the prefix, use alphabetical order. For example, A, B, C, D. Which one come first? Now B come first before C. So you go first do bromo before you do wetin? Chloro. Okay, for the wetin? For the prefix side. Then for the suffix side, also do the same thing for the suffix side. Alphabetical order. All right, alphabetical order. Always name in alphabetical order. Okay, take note of the type of chains. That's the next one. Types of chains. Okay, of chains. Types of chains. This one is common in geometric isomerism. I already taught this before. Okay, so we have two types of chains, geometric isomerism. We have cis chain. Okay, we have cis chain. And we have what? Trans chain. Okay, we have cis chain, we have what? Trans chain. So for the cis chain, you are going to see something like, let me show you how to know the cis chain. Okay, this one is the cis chain. So this is a cis chain. All right, this is a what? Cis chain. Why is it called a cis chain? Because the dimension of the chain, the arrangement. Okay, you have the two atoms and the substituents, they one side. It is either say the two substituents, they one side, up or down, and the two atoms, they up or down. Now this one they call cis chain. So if you want to name this organic compound, you are going to count the longest carbon to carbon chain, which is called the parent chain. All right. So we are going to count to favor the functional group following the hierarchy. And here, which functional group do we have here? We have one functional group here, which is the in. Look at it, E-N-E. The in, this double bond. Okay, the in, alkene. All right. So if we want to count now, longest continuous chain. If we count from here, 1, 2, 3, can you see? 1, 2, we have gotten to the double bond or the functional group. If we count from this side, 1, 2, it's still the same thing. So if we count from right to left or from left to right, it's still the same thing that we get. So we are just going to pick one. So we are going to left with 1, 2. That's 2. Okay, 2. That's where we have the iron. So counting all the longest continuous chain to get the parent chain, we will now count 1, 2, 3, 4. Okay, 1, 2, 3, 4. And 4 is what? Prefix of 4 is what? Boot. Okay, boot. All right. So we are now going to do what? What kind of chain is this? The type of chain that is this is what? It's a cis chain. So we are going to put what here? Cis. Okay, cis. It's a cis chain. All right. So what is the what? Is the functional group? The functional group is in. That's the what? The suffix. And remember the rule that states represent the location of the functional group with a number. So remember we are counting to favor the functional group so that the functional group is going to get the lowest number when you count. If we count from here 1, 2, okay, we are left with 2. If we still count from here 1, 2, it's still the same 2. So we are going to pick 1, 2 now, 2 now, the same thing. So we pick 1, we are now going to say 2. What is the suffix? In. Okay, that's 6 boot 2 in. That's what we have here. All right, let's look at the trans chain. The trans chain is, you will see something like this in trans chain. Okay. Okay. Can you see what happened here? The substituents, they up, substituent, they down, everything come miss. Okay. The cis chain, you have the substituents either up or down. Okay. The substituent, one go dey one side up, the other one go dey one side down. But for trans chain, you come like say everything transfer. This one from here transfer go down. This one you can't get something like cross like this. Something like cross. Okay, like this. Okay. So you see substituent up here, it's still dey down. You see hydrogen atom for up, you still see am for down. Okay, it's not the most that hydrogen atom that will be here. Anything can be there, but I'm just telling you that it will now you now have a mixture. All right. So if we want to name this one, first of all, we do what? We count the longest what? Continuous carbon to carbon chain. Okay, so that we get the number of the parent chain, so that we can what? We will know the what? The prefix. All right. So we count 1, 2, 3, 4. So 4. 4. That's the what? The longest continuous chain. 4. And 4 is what? Is known as what? Boot. Okay. The prefix of 4 is boot. Okay. So now we want to number so that we can assign a number to this what? This the functional group. So we are going to count to favor the functional group. If we count from here 1, 2, this functional group gets 2. Okay, we count from this side 1, 2. The functional group still get 2, so it's still the same thing. Remember, we are counting from the side that the functional group is going to get the lowest number when we count. So we are now going to have what here? 2. So what functional group is this? Is the what? The alkene. Alkene. Okay. Since it's the alkene, we are going to take this in. Okay, and put it here. In. Okay. In. So what kind of chain is this? Is it a cis chain? Is it a trans chain? Is it what? A trans chain. So we put it here. Trans. So this is trans boot 2 in. Trans boot 2 in. as simple as A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Now, let's move straight into exercise.